new video. We are going to study photoelectric effect in 1 minute. So, what is photoelectric effect? We'll see there. Suppose this is a metal. Let me draw a pen. Yeah, this is a metal which has a very low ionization energy. Why I'm saying very low ionization energy? Because if the ionization energy is very huge, then ejecting an electron out of here will be very difficult. Okay, so we take a metal, for example, we take cesium because it has a very low ionization energy. So what happens is we eject a light. So this is a light, and light contains what? Photons. We know that light contains photons. Photons are what? Quanta of energy, packets of energy. Okay, so what happens next is when photons are ejected on the metal surface, it gives some energy. They passes some energy to the metal, and that energy is used as a ionization energy. So electrons are ejected from their outermost shell. For example, this is the atom, the nucleus, and this is an orbits. The outermost electrons get ejected out, and when it get ejected, it travels here, and the circuit is complete, and we can measure current here. There is a current. So this is all. Everything is what is happening here, and this is called photoelectric effect. The thing we need to know is that we have to read a formula here, that is kinetic energy is equals to h nu minus phi. What is this kinetic energy? Kinetic energy of these electrons. Okay, the velocity of the electrons correspond to the kinetic energy, and h nu is what? The incident light energy. Whatever light we are we are putting on the surface, that is h nu. And what is this phi? Is that the threshold light, the threshold frequency. Okay, phi is equals to h nu naught. This is threshold frequency. And what does this means is whatever light we are incidenting, it should have a minimum threshold frequency to eject out the electrons, to complete the circuit, and to have a net current. And it does not depend on intensity. We have to remember this. It does not depend on intensity. What does this mean is, if I have a very bright light, but it has a very low frequency, then current will not flow. I will be zero, the kinetic energy will be zero. The electrons will not flow from here because it does not have the enough energy to eject out the electrons. Okay. If the light is dim, intensity is very low, but the frequency is high. What does the frequency means is this, and low frequency means very longer wavelengths. Okay, high frequency means high energy. Okay, because you can see the formula here, energy directly proportional to frequency of the light. With the frequency is very high, the energy of the ejected light is very high, so the electrons can very easily ejected out. Okay, so we can see a current. Okay, so this intensity thing, if you have to draw a graph between intensity and as you can see kinetic energy, it will be straight because it does not depend on intensity of the light. Okay, and if you have to see the graph between the kinetic energy and frequency, yeah, it increases. When increase the frequency, the kinetic energy of electrons increases. So this leads to a different phenomena, also called quantum chemistry, which we will discuss further in the next videos. So this is all for the photoelectric effect.